Good day. Since we now understand the difference between power and energy and how to determine the energy use of your building, we will start to look at step 0 of the new STEP strategy, research. In this lesson I will focus on the climate in which your building is situated and what that means for our building design. Universe, sun, moon, greenhouse effect, oceans, land, ice caps, all factors that have created a planet with different climate zones and ocean currents that transport heat and cold across the planet. Here you see different climate zones, as classified by Köppen and Geiger. Every color depicts a different climate. Let's have a look at the best known climate types. These are the data of a tropical climate, such as Middle Africa. If you look at the graph well, you will see that the temperature is always high and that there is a wet and relatively dry season. What you cannot see is the high average humidity. The next climate is that of a desert, such as in Northern Africa. Hardly any rain and a difference between winter and summer. What you cannot see here is the diurnal differences, which in such a hot and arid climate can differ a lot. It can be freezing at night and sizzling during the day. Here we see the temperate climate, such as in the Netherlands. Relatively cool temperatures, not too much difference between summer and winter, and precipitation all year round, but not as much as in a tropical climate. This is the continental climate, as in Russia. It resembles the temperate climate, but is more extreme in summer and winter, and there is also more seasonal difference in precipitation. And finally, we see the polar climate, with the lowest temperatures of course, but with an enormous difference between winter and summer. There is very little precipitation, mostly snow. Now, if we look at all these differences, it is strange that buildings look the same everywhere, especially if you look at offices. Just seeing these images, there are several features you cannot distinguish. First, the location of these offices, and second, the orientation of the building. All elevations are the same. Understanding the climatic differences, designing these buildings and keeping them comfortable is only possible thanks to the technical building services, which can correct the mistakes of the architect. In one climate they help to cool, in another to heat, and they can change the humidity. This however costs a lot of energy, so if we want to save energy, the first thing we have to do is design for local circumstances. In that sense, locality means that the building fits the characteristics and the climate of the site. Other terms that reflect this principle are genius loci, the spirit of the place, bioclimatic design, buildings that are adapted to the local climate, and vernacular architecture, architecture that has historically evolved due to local availability and lack of resources, when people had to solve things differently. For instance, in the tropics, where temperatures are always high, vernacular architecture makes optimal use of the cooling capacity of wind by creating air permeable facades and floors. But roofs need to be suited to withstand heavy rainfall, and buildings should be put on poles to keep out animals and also to create a maximum air current. In desert areas, we see narrow streets for shading, houses with a lot of mass that temper diurnal differences, white plastered surfaces to reflect the sun, and flat roofs that can cool down under a clear night sky. And in colder climates, buildings need to be well insulated to preserve the heat and have steep, pitched roofs to keep out the rain and carry the burden of snow. So, every building demands its own best local situation and solution, but its design can be approached similarly, which we will try to teach you. Let's see which climate aspects you need to know before you can design a sustainable building. Temperature. It's good to know the annual mean temperature, but also the diurnal differences. Humidity. Both the absolute and the relative humidity are important to understand what you can do with heating and cooling. Sun. You need to understand the course of the sun through the sky, as well as the solar intensity. Wind. A climate rose tells you the predominant winds, and if you understand the topographical situation, you can tell if these winds are mainly wet or dry, warm or cold. Precipitation. Annual values and seasonal differences are important to know. Soil. The underground and its geology define the options to use soil energy. And finally, surroundings. Mountains, trees and buildings can cast shadows onto your building, and there may be different local energy potentials you can utilize. We cannot go into all these aspects, but let's have a look at the sun. This is the sun chart of Delft, my city, at 52 degrees northern latitude. Every place on Earth has a different sun chart. I will explain this particular chart step by step. First, this middle line depicts the south. Most people know that the sun course is described from east to west. This happens exactly around the 21st of March and the 21st of September. From an azimuth of 90 degrees off the north point, east, to 270 degrees, west. The sun reaches its summit at 38 degrees altitude, at midday, and if you look at the little house, you see that the insolation will be at this angle. In summer, on 21st of June exactly, this is the track of the sun through the sky, from around 50 degrees of azimuth, northeast, to 310 degrees northwest. At midday, the sun reaches the highest altitude of the year, 63 degrees, and it reaches the house at this angle. In wintertime, 21st of December, the sun only peeps above the horizon shortly, from 130 degrees southeast to 230 degrees southwest. And the maximum altitude of the sun on this very day is only 15 degrees above the horizon. Here you see that incident on the house. Now, I want to ask you, where do you think does the sun hang in summer at 12 o'clock on your watch? It's here. Weird, eh? It only reaches south at this time, 20 minutes to 2. Why? Because of two phenomena. First, Delft is about 40 minutes behind Berlin, which is the demarcation line for the Central European time. And second, it's summer, so we live 1 hour later due to the summer clock shift. And where is the sun in winter? At 12 o'clock on your watch? That's here. It reaches pure south at 20 minutes to 1 because we don't have a summer clock anymore. Now, why is this important to know? Well, if you know where the sun is at which moment of the day, you will be able to design the right spatial configuration, glazing and shading for specific functions in a building. It starts with the sun, so always put a north arrow on your drawings. You cannot design an energy efficient building if you don't know how the sun turns around or over it. Okay, that's enough for this lesson. If you want to know more of the climate in your own region, I can recommend these sources for you. Your own National Meteorological Agency, a program called Climate Consultant, free to download, and sun charts provided for free by the University of Oregon. Good luck, and see you next time when we will discuss smart bioclimatic design.